Thank you. Fourth time. Now I'm calling Mr. Richard Elmer from Knight Pistols in UK to give us a presentation, last but not least.
Right, first of all, thank you very much all for staying this long. I can only assume you're here just to hear this super exciting talk that I'm about to deliver, because it's the last one of the day. I won't keep you all too long. I just wanted to run through some of the common challenges there are with tailings management, the considerations that a tailings designer has to go through, and talk about a couple of projects that are relevant to here. A project in neighbouring Bosnia, and also one up in Scotland that I think are good examples of how tailings can be well managed with minimal impact on the environment. Just interestingly, that photo there is of another Nevsun project. That one's in Eritrea. So just a quick bit about Knight Pistols, just to establish our credentials. We're nearly 100 years old. We've been working on tailings since the 1940s and worked on over 500 separate tailings facilities in the past few years. Myself and my colleague Lucy over there are based in our London office, and we cover projects pretty much globally. We've worked in about 30 odd countries from our London base, and we're currently working on a number of projects in the region, including those in Serbia and in Bosnia. So the challenges that tailings give us today, there's issues, as plenty of previous speakers have said, of space. Where can we put this huge amount of waste that comes out of the mines? Obviously, putting it back underground is a good option, but you can only ever put a small proportion of the material back underground. It's a costly business. Building a large-scale tailings facility is very expensive, and so we look to try to spread the cost over the life of mine. As mentioned again in this session, the potential for contamination is high, particularly on older facilities such as the one in the photograph, which is in this country, I'm afraid to say, but is an example of where water emanating from the base of a tailings facility can lead to contamination of watercourses. Often, mine waste is treated as an afterthought as well. You can have as many million ounces of gold in the ground, but if you've got nowhere to safely store the waste from it, you still haven't got a mine. So the things that we look at, I was asked to give sort of like an international flavour of how we go about designing tailings facilities for this talk. So we look around the world and pick the best bits of the international standards. The International Committee on Large Dams, the Australian National Committee of Large Dams, the Canadian Dam Association, also the EU Waste Directive, all combined together to give solutions that are the best available technology. Location is obviously hugely important, and we need to look at topography, the climatic environment, potential receptors of any contamination, and look at economic factors as well. So it's a combination of engineering, environmental and economic factors that lead to the optimization of the location of the tailings facility. Hugely important to characterize the site, doing geotechnical investigations, characterize the tailings that you're going to be storing, looking at the physical properties and the geochemical properties. You need to look at the capacity. There's a long list of criteria that need to be met for the design of a safe facility. Particularly looking at potential for seepage, the stability of the facility, the design of the lining to minimize any potential seepage. Massively important to the whole process is surface water management. That's one of the key issues. Where there have been problems with failed facilities in the past, it's usually poor water management that leads to the problem. And it needs to be operated properly. And most importantly, the closure design. Again, that's been alluded to on a number of talks today, looking at progressive restoration of a facility, making sure it's monitored properly, looking at post-usage, post-closure usage, whether you put it back to farmland, installation of solar panels, maybe return it to parkland. They're all potential uses to return the ground as it was before mining was undertaken. So a couple of examples. This one is in Olivo, a mine run by Minico. There's Minico representatives in the room if you want to find out a bit more about the particular project. But this is a small-scale sericite lead mine. It's got a couple of million tons of waste to be disposed of. It's on an interesting geology. The location that's put aside for the tailings is on karstic limestone, and the limestone is an aquifer, and the local town draws its water supply. So we undertook lots of studies to assess the best option for this site. We looked at conventional slurry tailings with a dam, and looked at filter tailings. One of the key things today is moving away from conventional slurry tailings, which are difficult to manage. It's costly to create an embankment to contain them. It leaves a long-term legacy that's hard to deal with. So our conclusion to trade-off studies at Olivo was to use filter tailings. The filter tailings is a product that's more akin to a soil, so you can then build a structure, safe, stable structure out of the filter tailings product, rather than having a big lagoon that's there for a long life. So that's a picture of the design as it is in its ultimate state. So it's a safe, stacked facility that has minimised the impact on the environment, minimises the footprint. And in the long term produces the most cost-effective solution for what's a small underground mine. Similar project up in Scotland, a small gold mine. This is a project that's in the national park, actually within the national park boundary. There was a previous design that was a conventional cross-valley design, which was an extremely expensive design to build. It was using slurry tailings, and there was a very large separate dam for water collection, a significant river diversion, and very, very high capex. So we reviewed that design and have now proposed a stacked tailings solution where the tailings are filtered, and creating individual stacks that represent that's sympathetic with the existing landscape. So we're creating individual mounds of tailings that look like the glacial moraine deposits that are common in the area. So it blends into the landscape. It avoids having to do the significant river diversion, and it appeals hugely to the operators, to the permitters. So I think that's pretty much just a summary of a couple of quick examples. The only thing to add is really that a tailing solution is unique to each mine. It is possible to get regulatory approval in very sensitive areas such as national parks if the design is done very carefully and working with the regulators to achieve that. Filter tailings aren't just for the massive South American mines. You may have heard of them being used in, but they can be used very effectively in small, narrow vein deposits, such as is very common across the Balkans. It allows the cost to be spread across the life of the mine rather than having a large, expensive facility up front, and has inherent environmental advantages, and it very much appeals to regulators. So I think that's just pretty much a summary of what I have to say. Thank you.
Thank you, Richard. Is there any question from audience? No? If someone offers a beer, I will not make my questions as well, so. No offers?
Sorry, Matt, but let's say, how many mines do you think where there are currently where, let's say, the concentration of the ore in the tailings is actually maybe in excess of what is coming out of the mine today?
No, that's a very common problem. It's first been exploited, I think, probably in South Africa, where they realised that there are significant amounts of gold in the gold tailings, and there's been a thriving industry there over the past 15, 20 years, reworking gold tailings because the gold recovery process has improved so much over that time. There are mines that we're working on today that have very high concentrations of the material that was supposed to be extracted still in the tailings, and one mine is looking at reworking those tailings. So yes, there are a large number. There aren't as many as there used to be because say where the big amounts of money were to be made were in the South African deposits, which had grams per tonne at levels much higher than a lot of open pits were working at. So, yeah, there's a significant number. I couldn't put a number on it, but there's a significant number, yeah.
Thank you, that was my question too. No problem. Yeah, no problem. One question for you now. You mentioned some 16% of your products goes in the flue gas purification or desulfurization. So this theme is very interesting for us here in Serbia because we have thermal power plants which needs to be, let's say, upgraded with desulfurization units. So can you explain the benefits of using a lime and, let's say, influence of different qualities of lime in this process of desulfurization? For example, you have two lime quarries with different kind of lime exploiting, and etc., etc.
Okay, thank you very much for the question. Let's say on flue gas desulfurization, it's a complex area, and especially when it comes to coal power stations at the moment. Because at the moment, nobody really wants to put capital investment, major capital investment into these facilities. Right now on coal power plants, a technology that we are promoting a lot is dry solvent injection. This is using a very specifically designed high efficiency lime hydrate that has got very good sulfur capture properties as a retrofit to pull a coal power station into specification. Now this actually leads to a lower capex to do it and a high operational cost for the reagent. But in many cases, people are much happier with that option than, let's say, the 100 to the 200 million euro capital on a wet scrubbing system for it. Now, to go on to just a second part is, today we're seeing an awful lot more emission control on ore processing. Sinter plants in steel shops are very much getting a lot of attention on emissions. And one of the benefits of lime and hydrate as a desulfurizing agent is that it's also very effective on capturing HCl and HF emissions. So you're getting a multimodal sorbent in many of these applications, which again gives a benefit on this. And the whole chemistry around different deposits in this one can lead to very different performances in hydrate functions. It may be calcium hydroxide, but the way that the base limestone form will affect very much the pore size and the surface area, and the pore size and surface area affect very highly its efficiency as an reagent in these processes. So an interesting area for sure.
Could be discussed very long, I see, yeah. Thank you. One short question for the end is to Mrs. Sabina about, let's say, experience in mining waste management in the region or Europe. Are you aware of some experience of this around?
Pa konkretno za sve zemlje članice Evropske unije postoji obaveza transponovanja implementacije direktive o upravljanju rudarskim otpadom. Na koji način je to organizovano, ne znam tačno kako je u većini zemalja u regionu, ali znam da od same organizacije zavisi i nadležnost ministarstva. Vi se svi sećate da smo mi nekad bili deo ministarstva rudarstva i prostornog planiranja, pa smo bili deo energetike, sad smo samostalno ministarstvo i u tom kontekstu i nadležnost na nekim objektima, u ovom slučaju upravljanja rudarskim objektom, je različita u zavisnosti od toga kakva je organizacija ministarstava u zemljama u regionu. Jedno je sigurno da zemlje koje su članice Evropske unije moraju da transponuju i implementiraju direktivu. To bi ukratko bio odgovor.
Thank you very much. So all goes to the directive. Thank you once more. Last chance for a question from audience. You have your own.
Quick question in return. So I was very interested in the lime stabilization part of what you said. I was just wondering whether a technique like lime stabilization is likely to be applicable only in areas of high land values, just because of the expense of it. Is there a sort of a sweet spot where that would really work, or is that applicable, across the globe?
We've actually developed a range of materials of varying prices and functionality, Stabicalco as a range, where we're using lime as a constituent on this. Lime gives a benefit in a lot of the stabilization parts, not just by giving strength, but also actually locking in some of the more hazardous heavy metals, which can be exceptionally valuable in certain cases. And we've developed let's say a good understanding of how to create a much more tailored mixed product towards these applications to balance both the cost